dear students, in last video we have studied about the applications of second applications of Gauss's law. In this video we study the third applications of Gauss's law. Then the third application is electric field due to an charged infinite plane sheet. Here we consider a plane sheet which is uniformly charge distributed having surface charge density sigma. Means this plane sheet consists of each charge is distributed equally and they having a surface charge density sigma. Then the notation of the surface charge density is this: sigma is equal to q upon a, means charge per unit area. Then rearranging this term in the form of q is equal to sigma into a. Then E is the electric field which is perpendicular to the plane sheet and which is directed outward. Here consider to find the electric field intensity at point P. Here we consider the Gaussian surface around this point P which has in the then this Gaussian surface which is in the form of this cylinder, and the area of this cylinder is capital A and the length of this cylinder is 2r. Here consider a point P which is situated at a distance r from the plane sheet and has the electric field intensity is E bar. Then again consider the either sides of this plane sheet. Consider there is a P dash point which is situated at the same distance, means a small r, and has the same magnitude E bar. Means so r and r total distance of this cylinder is 2r. Then this plane sheet which is passing through the center of this cylinder, which is both these two ends of this cylinder which is passing through the center of this which is equidistance. Then both these two ends which is equidistance from the plane sheet. Here we find the electric flux which is passing through the closed surface. Then electric flux is equal to the, here we calculate flux at point P. Here we integrate E into ds bar ds at point P, plus we find the flux at point P dash. Here flux at point P dash E into ds P dash. Here we know that according to the Gauss's law, E into ds cos theta, but the angle is 0 because electric field and normal to this surface is on the same line, so angle is 0. If the angle is 0, then cos 0 is 1. So this value eds cos theta, this value gives eds. So here we take only eds. Then here we integrate this eds. Then phi is equal to, here E is outside the integration and ds because E is constant, and this is the equation at point P. Then plus the E into integration of ds at point P dash. Means here we calculate the total flux which is the addition of flux at point P and the flux at point P dash. Here we know that the surface of this cylinder is A, so here substitute total area of this cylinder is A, plus here also total area of this cylinder is A, means EA plus EA means is equal to 2EA. This is the equation of flux, and this equation is the equation 1. Then according to the Gauss's theorem, we know the formula for the Gauss's theorem, Q upon epsilon 0. Here this is the Gauss's theorem. Then this term we know that we substitute the value of Q. Here is the Q value. Q is equal to sigma A upon epsilon 0. Then this is the equation 2. Then from equation 1 and 2, consider equation 1 and 2. Here the left side is equal If the left side is equal, then the right side of these two equations also equal. So here 2EA is equal to sigma A upon epsilon 0. Here we find the value of E, means electric field intensity. Thus rearranging this equation in terms of E, here sigma A upon 2A epsilon 0. Here A get cancelled, and then last equation is sigma into 2E0. Here is the here is the value of electric field due to an charged infinite plane sheet. Thank you.